to see. I'm going to send this to my parents. Oh no, I'm talking. My parents are going to yell at me. No. What this is for, twofold. One, if you're absent, you can go onto Google Classroom. You'll see the YouTube video, and you can watch the actual lesson, okay? A lot of times you'll come in the next day if we're practicing, grab a Chromebook, grab headphones, and just start taking notes, okay? Or if you go home and study, or if you don't understand and if you're afraid to ask the question in class and you don't understand what's going on, you can watch that video again, so this way you can understand it better, okay? I'm trying to give you the tools necessary to study for this classroom, all right? So me recording is not an I got you. Got it? It's just a tool for you. Cool? Thank you. All right, then let's get started. If I go too fast, if you don't understand me, if you can't see anything because my head's going to be down most of the time, let me know if I'm off screen or if you can't see anything, okay? All right, so let's start. We're going to always title it with the date. Today is the 27th, and the title of the actual lesson. So that this way, if I say, hey, go to your limits notes, you know what notes were the limits. So you can go through the top of your page and see what those were. Does that make sense? Okay. So today we're going to talk about limits of functions and their definitions. Limits of functions and their definitions. So today's main lesson has to do with limits. The definition of a limit is as follows. The value, what that means in math terms, is a number or variable of a function or graph as the x value gets closer to. In math, we say approaches. Another number. And this number is going to be the value of your function. So this is going to be your y value or your f of x value. I'm going to move up because I see some people like craning their neck. Is that good? Is it too bright? Is it too dark? Is it okay? Any opinion at all? Good? Okay, thanks. All right. In math, we hate writing things word for word. So as you know, in math, we use a lot of notation and a lot of symbols. So here's your first calculus notation. So the notation for limit is as follows. The limit, this is an L because if I just write the straight line, some people think it's a 1. So that's an L, okay? The limit as x approaches a of f of x is equal to b. In my almost 15 years of teaching, I still get students who don't use correct mathematical vocabulary. That's because you don't know how to read the symbols, okay? So I'm gonna write down how it's read. So this way you know how we read this in math, okay? We read this as following. The limit. Because we don't say lim x arrow a f parentheses x parentheses equals b. We don't say that. We actually use correct mathematical vocabulary to use this. So we read this as the limit. So this means I'm going to write down the symbol underneath the actual definition or the actual like sentence part. So the limit as x approaches, a. So x approaches a. So this limit goes with this. I'm sorry, this goes with this. This goes. Does that make sense what I'm doing? Okay. The limit as x approaches a of f of x equals b. Equals b. I know this is all new and this is just notation and vocabulary, but are there any questions or any explanations you need so far? Are we sure? Am I moving too fast? Okay, I'm gonna keep going at my speed until somebody tells me to stop. Okay, sound good? Okay. Do this. Okay, some specifics about A and B. This is really important because we need to know what A and B can be in math. Like what values can it represent? So A and B can be the following. A and B can be numbers, decimals, whole numbers, positive, negative, square root, fractions. They're numbers. It can be any of those things. The other thing that A and B can be is positive or negative infinity. This is infinity. We'll do infinity. Oops. So that's another thing that it could be. The other thing that A and B can be is, actually this only applies to B, sorry. A and B cannot exist. Sorry, B actually. We have to have always some kind of A. We call this does not exist. Only for B, actually. Sorry about that. Meaning that there is no defined number. I see some of us looking up. Can I go down? Is that okay if I go down right there? Does anybody need me to go back up? Okay. Forgot. Okay. So these are the two things that we're learning today. We're learning about actual numbers, and we're learning about what it means to does not exist. We've got two more things to talk about before we get to the examples. We got a definition and then a very important rule that we need. Can I get a thumbs up when you're done writing this so I know when I can move on? Okay. Okay. Do you need me to move up? Okay. Do you need me to clarify some writing? Okay. You sure? Good, good, good? All right, everybody ready? No? Yes? I'm gonna move, and then if you need me to go back, let me know. Nobody said anything, so I'm gonna keep going. Okay. I hope we get comfortable in this class soon enough. Don't be afraid of me. Only my advisory really needs to be afraid of me. Not really, though. No laughs, thanks. Point of discontinuity is our next definition. Points of discontinuity. The point of discontinuity is a point or points on a graph or the value of a function where the function is undefined. Undefined means it has no value. Oops, sorry, I was off screen. This could be a hole in the function, and you'll see what I mean by hole, or a jump in a function. And these things may affect the limit, okay? These things may affect the limit, so we need to understand what they are. We're not sleeping, right? Rafa, we're not sleeping, right? Okay. All right, the last thing before we get to our examples. This is really, 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 really important. Actually, this is the most important thing for limits. Because if this thing does not happen, then the limit doesn't exist. And we'll talk about that in a second. For a limit to exist, which means that it has a particular value, both parts of a graph what that means is the left and right side oops, writing too fast. Must reach the same point or value. Off screen, sorry. We'll explain what that means in the examples in a minute. We got out of here at what? 30, nope. 29? Nope. Does anybody know what time we get out of here? Yeah. When you go up there, can you see what time we get out of this class?
29.
I'm sorry?
29.
Oh, I was right, 29. Okay. When you're done writing this down, I need you to take out that example sheet that I passed out. Keep out your notes if you need them. So we're going to use them side by side. Okay? If you need to, we're going to use them side by side. I'll leave this up for a minute. Go ahead and talk for like a minute while you get settled. 29. So 27 minutes. Yeah, that clock doesn't work. Don't look at that clock. That's why I have that one. Yeah. That's why I That's why I bought that one. That and kids can't tell time on a clock. What? Why'd you laugh? It's true. I mean, you're right. I'm making a general statement. However, there are a lot of students who cannot tell time. Are we good? Are we ready? We're ready? Okay. All right. Let me. Oh Jesus. Amelia.
Yeah.
Where did I put my son's There's nothing.
I don't know where you're
I got one. Okay. All right, seniors. Let's bring it back. Don't make me count down like a child, please. Thank you. All right. Okay. So we can estimate limits from functions and graphs, okay? From tables and graphs. So we're going to do one from a table, okay? This tells me to estimate the limit, meaning that we're looking for the y value or the f of x value. That's what we're looking for. We're looking for y and f of x, okay? Y or f of x. They're the same thing. Then write the limit notation. So we're going to need to write it as this. So first we're looking for the y value, and then we're looking for the limit notation. When we're doing limit notation, for the time being, all we're doing is replacing a and b, okay? For the time being, all we're doing is replacing a and b. Got it? Okay, so let's look at this example. The first thing you want to do is you want to find the x value it's getting closer and closer to, or rounding to, okay? I'm going to zoom in. Is it okay if I zoom in there? Is that good? Okay. So if we look at this, if we look at the x value, what is it getting closer and closer to? 1. Yes. X is going to be approaching 1. X is going to approach 1. Because basically you're rounding, right? We're going to look at this last one. This rounds to what? It rounds to 1. So this is going to be x approaches 1. 1 is going to be what letter in my limit notation? A. Good. How do you know that? How do you know that? Yeah, the x is right there. Okay? There is no surprise. The x is right there. Questions? Okay. So the next thing you want to do is you want to find the y value. Find y or f of x. F of x and y, remember, are the same thing. Okay? So very similar to what we did for x, we're going to do for y or f of x. What is y or f of x getting closer and closer to? 3. Yes. Why is it getting closer and closer to 3? Yes, because we're rounding. Nobody said that, but I just said it. What letter is this going to stand for? B. Very good. How do we know that? Yeah, because it says f of x is equal to b. Questions? So far, so good? Okay, so now we're going to write it. The limit as x approaches what? 1 of f of x is equal to what? 3. Questions? You sure? Huh? Solve it? We're not solving it. There's no solving. This is writing the notation. Okay? We'll get to solving limits later on, like in October. Okay? We need to understand limits first before we start solving them. Okay? Questions? All right. For sake of time, I'm going to skip the second one, and I want to talk about the graphs because we need to understand the graphs in order to do this problem on the back. Okay? We need to understand the graphs in order to do the problem on the back. Cool? Okay. All right, so let's look at this. Can somebody read this out for me? It's okay. I'll read it then. We're shy in the first week. For each of these functions, the limit as x approaches 2 of f of x is equal to 4, meaning that every single one of these has a limit of 4, okay? It has the value of 4. We're going to look at these and see why it is, okay? So if I look at this first one, I'm sorry, did everybody have this down before I moved on? Okay. If I move, just tell me to wait, okay? We're going to look at this first one. They already told us that the limit was 4. We're looking at 2. So what I like to do is I like to draw a dotted line at the value that they're telling you. If you want to use a highlighter, if you want to use something else, that's fine. Some people use a post-it note so they don't have to draw it, okay? Got it? So whatever you do to understand where it's coming from, do that. What you want to do is you want to go from left to right, because remember, it has to go to the same value. From that line, and then right to left from that line. Am I off screen? Okay. So I'm going to start here, and I'm going to go until I get to that value and circle the point. Okay, I see some confused faces. So I'm on my graph, right? I'm trying to find the value for this function from both sides of it, right? I need to like basically connect to a specific dot. So imagine connect the dots, but you're just trying to make lines to connect one dot, okay? Instead of making multiple lines to connect multiple dots. So it gets to this point. From the left to the right, it gets to this point. Any questions so far? Are we sure? Okay. Now we're going to go the other way. I'm going to start on the right side of the graph and go here, and I get to that same point. So because I get to that same point, the limit is 4 because my value is 4. Questions? You good? No. You confused? You want me to do it again? No? Okay. You sure? Okay. Does anybody want me to explain it again? Are we sure? Okay. So that's why the limit is 4 here. Basically, I'm using my fingers, trying to get to that point, and that point is 4. Okay? Questions? All right, then let's look at the next one. Again, here's 2. There's 2. I'm going to go from the left side of my graph until I get to that point where it crosses that dotted line, that vertical line. Then I'm going to go to the right side until I get to that point. And that is also 4. So that's why this limit is 4. But wait, Miss Santana, what about that dot on the bottom? What about that coordinate on the bottom? This coordinate does not matter right now. This coordinate does not matter. It's there because, you know, the function is defined at that point, but remember, limits are where the graph approaches, not where it equals to. Where does it get closer and closer to? It gets closer and closer to 4. It doesn't even touch this number down here, right? It's like you and one friend walking towards each other on the street, right? But then your other friend is across the street. Your two friends you two are getting closer together, even though you have a friend over there, okay? The limit is like, here's the light pole, right? We're getting closer and closer to the light pole. There's the limit. The light pole is the limit. That is where you're going to get closer and closer to. Does that kind of make sense? Okay. We sure? All right. I'm not going to go over this one because that one's easy. All right. All right. Flip to the back. We're going to go over now. Am I going too fast? Okay. We're going to go. Ooh, somebody said yes. Does anybody need me to go back? Okay, I see some confused faces. When I come around while you're doing this example, please ask me questions, okay? All right, so we're going to go over now when the limit does not exist. I always use D&E. That's not proper mathematical abbreviations, but I learned this from my calc professor in college, so I'm going to keep using it, okay? We have 3 different cases where it doesn't exist. So let's look at the first one. We're still going to look at 2, okay? Still going to look at 2. I'm going to move to from my left side of the graph. Is my left side of the graph getting closer and closer to any specific y value? No. This is actually going to infinity, but I still have to do the right side. I don't have another highlighter. Is this one going to any specific number? No. That is why the limit does not exist right now. So we're just going to say the limit doesn't exist right now. Okay? We'll talk about this later. Right now it doesn't exist. Okay? Because it's not going to a specific number. So I'm going to write the rationale there. So, does not exist because there's no specific value as x approaches 2. You see I'm using symbols there. I'll move that up. How's that? Is that good? Okay. There's no specific value as x approaches 2. Questions on that? Sure? Okay. Can I go to the next one? All right. So let's look at the second one. Again, we're looking at positive 2. I'm going to go to the left and circle where that number is. What is the value there? What is the y value that this gets closer to? -1. This is the x value, remember? And this is the y value, okay? All right, so that's the left side. Now let's look at the right side. If I go from the right side and stop at 2, what is this value? 1. Are these numbers the same? No. Do they touch at the same point? No. No. So you see it jumps, right? This side jumps here, okay? It has to be the same value or both sides have to touch the same point, okay? That's why this right here is different from here because this graph touches that point, okay? There's no graph down here, so that's why does not exist. That's why it exists. So this one does not exist because there are multiple values for x. Okay? Questions on that one? All right, last one. Here's 2, right? We need to find the left side and the right side. Let's work with the right side because I can see your right side, right? So when I go to the right side, what is the value here? 0. So the value is 0. I'm going to cover up those so you can see. I'll wait until everybody's done. Okay. Now, if I cover up the right side of the graph, do I have a left side of the graph? No. If your function does not go from left to right, if there is no part of that, the limit does not exist because I can't figure out what's going on with this side, okay? So the reason it does not exist is because the left part is missing. I don't have a mathematical term for that, so we're just going to use SVU terms. Thank you for somebody laughing. I appreciate that. Are there any questions? Are we sure? Yeah. Yeah, hurry up. 29 we get out, right? You said? Hurry up. All right. If there are no questions, you have about 5 minutes to do the example at the bottom in your groups. I'm going to come around and answer any questions that you have, okay? So use your notes, use the examples to answer these problems. I want to see where you're going to head, so this way tomorrow during the practice, I can address any misconceptions. Cool? Alright, 5 minutes. Amelia, wake up. You can talk in your group at 11:01. I see people drawing the line. Start with drawing the line. Oh! Look at this. Sorry. This is not multiple choice. Not multiple choice. There are 4 different problems. Okay? It's not multiple choice. I'm sorry. I should have been clear. So your first part, you know what? Not multiple choice. So this first, I saw a bunch of you doing this, so I'm not just. The first one, you're looking for the value of the limit as it approaches -2. The second one, 3. The third one, 0. And the fourth one, 2. This is not multiple choice. Okay? 4 different problems using the same graph. Okay? I promise. You weren't doing it. So it's 4 different problems using the same graph. Yeah. 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 Right. We're looking at. Okay. So we're only looking at this one right here because it says 2. Right. Correct. Correct. So like for this one right here, right, it's -2. So we're only worried about what happens at -2. Yep. And then here we're only going to have to worry about what happens at 0. Okay? Got it? Yeah. That's -2. Okay. Yeah, maybe. Okay. So it's not like there's 4 different problems. Okay? So like that would be your first problem, right? You're trying to find the number, just like we did here. Right? We found the number that it got close to. Right? You're trying to find the number that it gets close to. So where's -2 then? Okay, draw a line. Do you guys need me to do the first one to help you? Okay. Because I'm answering the same questions. And that's okay. That's okay. Alright. Are we ready? Not ready? Well, too bad. Get ready. Okay. So the first one is asking me, again, this is not multiple choice. First one is asking me for the limit where it's -2. So I'm going to draw the line at -2. Okay? Questions on that? Are we good? Are we sure? Okay. Now, just like we did in the other graphs where we were showing, right? I'm going to go from the left side of the graph until I get to -2. And then I'm going to go to the right side of the graph until I get to -2. Are they the same point? Yes. Now we need to find the point. So we're going to go over to the y. What is that approximately? 0's down here. 1's up here. 0.5. Okay? So that is going to be equal to 0.5. Are we good now? Are we sure? Sure? Okay. All right? Good now? Okay. Draw the line at 3. Draw the line at 3. Draw the line at 3. Ooh, so close. Very good, very good, very good. So yeah, look where it's hitting it. It's not at 1. Oh, I see lots of lines. Very good. You're all drawing lines at the right spot. Good. Good. Remember, coordinate is x comma y, and we're looking for the y value. Remember, the coordinate is x comma y, and we're looking. Very good. Yes, that's right. Good job. Do you need the sheet so that you can write all that down? This one. That one up there. So you can write it all down. Okay, we'll grab it. Underneath the elm. The elm. The projector. Okay. Good, good. I see a lot of correct lines. You don't have to give a rationale yet. That's fine. I would. That is correct. Very good, very good, very good. I'm gonna stop the timer. Just keep working, just keep working, just keep working. I saw one person who had them all right so far. I see 2 people who have them all right so far. Ooh, C and D, check C and D. Check C and D. I see 4, good. Did I say 3? 4. Good job. A lot of you got B correctly. Draw the lines. You've got 3 so far correct. Good job. You've got 2 correct. One. Show me what you're doing. Okay. Does the graph though cross at 0? You're looking for where the graph crosses. So what is that? And? So we're looking for the y value. So then what would it be? -1. Very good. Draw your 0 is your x-axis or your y-axis. Okay.
No, I can tell that's 1.
Good. 0 is this axis. Okay.
It's right here.
Good. You don't need rationale. Very good.
Yeah, and I know it's negative, but I can't tell where it's at.
Okay. Yeah, draw that line's good. Now go from both sides. What is that y value? Remember your coordinate is x comma y. Good. Maybe I should stamp some paper. Okay, draw your line at 3. Where's 3? Nope. 3 is right here. So you see 3 -1? So draw the line to that point. Okay? But you have a coordinate, right? So then what is that? Negative what? Oh, no. Use the draw this. Use your not it's a straight vertical line. Okay? You know, you're not looking there. You're looking where your graph crosses this vertical line. Okay? You're not looking where it's crossing the axis. You're looking where it crosses this line. Yeah, -1. Good. Emilio, 0 is the axis. Right here.
Help me out with it.
We only have 3 minutes. Which, all right, seniors, go ahead and pack up. I need you to put the calculators away. You cannot be dismissed unless I have accounted for all my calculators. So we need to do this quickly. Tomorrow it'll be more accessible to you. I apologize. Quickly. Once you have returned your calculator, have a seat. Once you have returned your calculator, have a seat. Oh, thank you. Sharpie? No, I'm not Sharpie. Sorry. Not that I'll stick to that. Oh, why don't you put a piece of paper?
This one, using this?
No. Have a seat. So you can have it.
Here, I am missing.